talk about the basics of database management systems. In fact, we'll talk about the drawbacks of the file processing systems. Then we'll define what is database management systems. We'll give you different views of database. We'll talk about different database models. For example, a relational database is one such model. Entity relationship model could be another such database model. Hierarchical database, object-oriented database models, network database models, and so on. So we'll define different type of database models. And then we'll talk about some of the concepts related to the normalization, basic objectives of normalization, what is the first NF, what is the second NF, and so on. Let me first talk about what are the drawbacks of the file processing system. But before starting, let me give you some basics of understanding the topics related to file processing system. If, for example, today if you go to the railway reservation systems now, you go to the one counter and you get your tickets reserved for all the stations, for all the places, wherever you want, in all the different classes, different type of trains. You can get it cancelled also. You can get your ticket reserved for the forward journey also, that which was not possible earlier. For the cancellation, you have to go to different counters. For booking a ticket in a particular train from the first class or the higher classes, you have to go to different counters. For a particular train, you have to go to the different counters and so on. So this is basically one way to understand that earlier what we used to see at railway reservation system is an example of a file processing system, and what we see today is an example of a database management system. But to understand its advantages, the advantage of database management system, let's try to pinpoint what are the drawbacks of the file processing systems which are supported by the conventional operating systems now. So file processing system means that we have for every, there are different files, and for every file there are different type of applications and so on. So we have lots of drawbacks with maintaining files, different number of files or large number of files, and writing applications for each type of different files now. So let me talk about those drawbacks and then we come to database management system. What are the drawbacks now? First is called data redundancy and inconsistency, number one. We'll talk about each one in detail. The second one is called difficulty in accessing data. This is the second one. The third is called data isolations. This is third. The integrity problem. These are the drawbacks. Let's list some more problems are there with what we call the atomicity problems, concurrent access anomalies, and finally we have the security problem. So these are the 6 or 7 problems which we have with the file processing systems. Let's talk about each one in details. Now let's talk about the first one, what we call them data redundancy and the inconsistency problem. We'll give you some examples here itself. So basically what we are talking about is that in file processing systems we have a number of files. Since the files and applications programs are created by different programmers over a long period, the various files are likely to have a different formats and the programs may be written in several programming languages. What we are talking about, that we have a large number of files, large number of applications programs to process these files, and you have a different programmers to handle these files and applications programming. And moreover, the same information may be duplicated in single files. So what happens is that when you have a number of files, when you have a number of applications programs, so what happens, a lot of duplication you see. For example, take example of railway reservation systems now. Now, for example, you have 2 different counters for booking a ticket. For the same one counter booking for the second class, another counter you have it for booking a seat in the first class or in the higher classes now. So now we have duplicated data. Same number is being used at 2 different sites now. If you want to do cancellations, then you have to go to another counter. Again you have to maintain the record about that train also. So basically, for same type of job, so basically what we have done in 3 files, we have duplicated the information about the train number. Now, so the first drawback, when we maintain a large number of files, and then we have to write a large number of applications, and each file we have duplicated the item. Here we have seen in the case of railway reservation system where the information related to the train number has been duplicated in 3 files. It could be in some more files also depending upon what type of activities you are doing. Let's talk about the second one. What is the drawback what is the second drawback of the file processing system? What we call them difficulty in accessing data. Now look at this one now. What is the basic issue here? The point here is that the conventional file processing environments do not allow needed data to be retrieved in a convenient and efficient manner. More responsive data retrieval systems must be developed for a general use. What we are talking about here in this case is that since you are managing a large number of files, so accessing data from a large number of files is a very difficult task. the response time will be very, very slow. Compare that you have one program, you have all the files are stored at one place, you have merged all the different type of files into one file, and all files are being handled by simple one application program. So the response time will be much more faster in the database management systems where we are talking about integrated environment compared to the file processing system where we have a large number of files because the data has been duplicated also. So this is the second drawback. Accessing time is very, very slow in file processing system, whereas it is very fast, response is very fast in integrated environment for database management system. Look at the third issues now, which we are very much concerned in the file processing system, what we call them data isolations now. Look at what we have. Because data are scattered in various files, and the file may be in different formats. So all files might be different formats. Someone is writing one type of format, someone is talking about different formats, right? It is difficult to write a new application program to retrieve the appropriate data. So that is another problem. So basically mismatch, or basically what sometimes we call the portability problem, because all files might be having in different file formats. So again, there will be a problem in accessing the data or retrieve the data from these files. Let me explain you the terms, what we are talking about, the new terms we have brought it here, what we call them formats. For example, take example of a Unix operating system. In Unix operating system, the files are stored at, I'm trying to explain you the meaning of the different formats. For example, in one file, data could be stored as a record by record. In another file, data could be stored as a byte by byte. So again, there will be a problem of a mismatch. Here, this is the main issue now, that the files are of, all the files might be following the different formats. So data retrieval will be a problem in those type of situations. Let's talk about the fourth issues now, which we are concerned with the file processing system, what we call the integrity problem. In fact, this is the key issue in database design. If your database is not, if this issue is not properly addressed, then you will not get the correct result. Now what this is? Now here what happens, let me give you one small example. But in data values stored in the database must satisfy certain type of consistency constraints. For example, the balance of a bank account may never fall below a prescribed amount, say $25. That is the basically constant one has to follow. Developers enforce this constant in the system by adding appropriate code in the various application programs. So that I want to maintain this one, so accordingly I have to write a program for it. However, when new constants are added, it is difficult to change the program to enforce them. The problem is compounded when constants involve several data items from different files. So basically, what we are talking about is that if I want to enforce certain constraints, like for example, maintain certain date for doing something else, then in that case, it is very difficult if I want to maintain a large number of different type of files. So there will be a problem of integrity problems because the constants will not be able to enforce across large number of files. Constant means criteria. We have defined that if you are going to the bank, if you are having a check, the minimum amount must be kept into your bank account. So, and if you are maintaining a separate different accounts, then it is very difficult to maintain them. But once you have a database type of system, then it is very easy to maintain this type of constraints now. So this is the first. So this is the first problem, and what we call them integrity constraints. We'll talk about when we come to the database model, what are called integrity constraints or integrity rules. That in fact one of the most important rules in database management system. Anyone who is working on database platform must understand what is the integrity rules now. But here right now what we are talking about, the integrity rules which cannot be ensured when we are talking about this file processing system where we have a large number of different files. Atomicity problem. Now, atomicity problem is basically, that is again a very critical problem. What we are talking about is that when the transaction should be in atomic. For example, either transaction should be completed or fully, or transaction should not be completed at all. Let's look at this one, what this problem, and then we define this some example to it. Now, a computer system, like any other mechanical or electrical device, is subject to failure. It always happens. Sometimes power is failure, sometimes memory will fail down, sometimes other components of the hardware will fail, motherboard will fail, DNA chip will fail, and so on. So there could be many types of different problems now. So in many applications, it is crucial to ensure that once a failure has occurred and has been detected, the data are restored to the consistent state that existed prior to the failure. So what is the atomicity problem? For example, you have done some transaction, and in between, even if the transaction is not complete, halfway through you are about to complete your transaction, something has happened in the database. So now it means that either it should be rolled back. So database, the atomicity problem is related to that transaction should be complete. It should not be like half completed and half incomplete. It should be complete. Otherwise, the inconsistency in the database will be maintained. For example, I have gone to the railway station for booking a ticket now. Now, already the entry has been done. It is confirmed, but by the time you get your printout, there is electricity failure or the printer has failed and so on. This whole transaction is not complete. By transactions means the completion of the task, submission of the form for booking the ticket, entry by the operator into the database, getting confirmation from the database, and finally taking the printout. That becomes one transaction. That becomes one atomic operation. So atomicity problem means the complete transaction must be done. If something has happened in between, transaction should not be completed and database must be rolled back where from it has started. Means state should not be changed halfway through. It should be changed by one or must be completed, or if it is not completed, it must roll back to the previous state. So this is called what we call the atomicity problem. This is difficult to maintain in the different file type of systems now, because we are dealing with large number of different files where you have different sets of data. In database management system, you have this problem can be easily ensured, and most of the database problems, most of the database management systems are enforcing this constraint. Now we call them current. Now the next problem. Look at this one now, current access anomalies. Now what this problem is? This is another very important problem in the database. So what we have here is so that the overall performance of a system is improved, a faster response time is possible. Right? Now many systems allow, now today most of the systems allow today users to update the data simultaneously in basically multi-user environment or multitasking environment. Your database machine, the server is one, but the many users, they want to update database very fast. In such an environment, the interaction of the concurrent updates may result in inconsistent data. Now what we are talking about is that it might happen, database is one. Take for example a database management system. In database systems, you have only one database where might have lots of updates might be taking place concurrently. Now system has to update such a way that the consistency of the data must be ensured. At a time only one transaction will take place, but the request might be coming from the n number of users now. Take example of railway reservation system. In Delhi, all the reservation is being done by the main computer which is lying on the New Delhi railway stations now. But we have a number of terminals all across the city now. So the users might be going to those stations and booking the tickets. So concurrent requests are coming. Requests are coming in parallel from number of terminals. And system has to see that the updation should be done such a way, or retrieval of the information should be such a way that the information, that inconsistency should be maintained, or consistency should be maintained, or inconsistency should be avoided as much as possible. For example, what we are talking about, and this will be a problem when we are talking about concurrent updates or the simultaneous updates in the database. For example, if I have booked my ticket, then the number of seats available in the train must be reduced by 1. Or if someone has cancelled a ticket, then the number of seats available in the train on that day must be increased by 1. If it is not happening, it means that there is a problem of the inconsistency of the data, which always will happen. It's quite common a problem in the concurrent database. If you are working on your system alone, then there is no such problem like this, because you are modifying, you are getting your data results and so on. But if the same database is being modified by large number of users all across the country, then inconsistency should be the top priority, which is impossible to achieve when we are talking about the file processing system. But which is easy to achieve when we are talking about database management system, because we have only one database that is lying on the central place. Where in file processing system, that each file has own database and so on. So maintenance will be much more difficult to do it now. Now with all these backgrounds, now let me give you the definition, correct definition of database management systems. We are going to work on database management systems now, and we have some practicals not in CSI 14, but we can work here also on CSI on some Microsoft Access packages. but more database related practicals we will be doing in CSI 20. So you must understand what is a database management system. In fact, you must have got some exposure to Microsoft Access. This is also a database, relational database from the trimester 1 itself. So more detailed discussion we will be having in CSI 20 when we come to at the end of this trimester now. So let me give you proper definition of what is a database management systems now. Look at this slide now. We give you this exact definition of what is a DBMS is collection of interrelated files and a set of programs that allow users to access and modify these files. In major purpose, the file might be, you have many tables, but you have single applications now. The major purpose of a database system is to provide users with an abstract view of the data, right? Basically, the idea is the system must hide all the certain details of how data are stored and maintained. Even in database management systems, each table might be one database or one relations, but so you are maintaining large number of relations, but application is only one. And the basic purpose of database management system is to hide the details, how the informations are internally stored. As a programmer, a database programmer, we are not basically concerned whether information is stored record by record or a bit by bit or byte by byte and so on. We are not basically concerned with how information will be internally stored. We are more concerned with how to use the database, how to write an applications on the database. Whereas people who work with the file processing system, they might be a little bit more involved with the how information are stored internally. But problems of different kind of there. Here we are talking about basic purpose of the database management system to hide the details that how information are being. This is the same thing what we work with the operating system. When we work with operating system, we are not basically concerned only that how information are stored internally. We simply interact with the few utilities and we start working with utilities, icons and so on. But how information are internally stored, if not, we are not concerned. For example, when you send your email, you are not basically concerned how the information are being sent, whether it is sent by packet or datagram by datagram, or whether it is being sent through wireless network or the wired network, or whether you have a fiber optics and so on. You are not basically concerned. You are simply concerned with the package or the package which helps you to send the email to the recipient. So same purpose we have with database management system. But database management system users should not be concerned that how information or the file or the data must be stored internally. You simply concerned with the queries, writing applications, and so on, and create a different type of databases. Now, data abstraction. This term is data abstractions. The data abstraction terms you must be aware with your Java programming language. Now, for example, class is in a data abstraction problem. How information, when you write a program, you create a number of classes. Even if I have not created a class, I can use your class. So class gives the data abstractions now. Means one is not basically a user of a class should not be concerned how the information in the class has been stored. Right? For example, you have whether your name is of the 20 characters string or the 10 character strings, or whether you array of 20 bytes or 30 bytes. They are not concerned with the fields of the class. They are simply concerned with how to use that class. So class gives you a data abstractions concept. And many other concepts are there. But right now we are concerned with the data abstraction concept now. So database management system also talks about, also provides you this facility called data abstraction. Now look at this one slide now. What exactly we have in data abstractions in database management system. For the system to be usable, it must retrieve data efficiently. This concern has led to the design of a complex data structure for the representation of data in the database. Since many database system users are not computer trained, developers hide the complexity from users to several levels of abstraction to simplify users' interactions with the system. What we are talking about is that we hide the complexity, how information is stored inside. The database management systems have given a different level of abstractions of the data, so that users should not be concerned about a user of a database management system should not be concerned how information has to be stored internally. So we will talk about what are the different views of data abstractions. In Java programming, when class is only one abstraction, but here we are talking about different levels of abstractions now. Let's talk about what are the different levels of abstraction. For example, if you have done some course on the network, we say that any network systems gives a different level of abstraction. At the which an engineer is basically concerned that what are different type of encoding techniques. Engineer works with the signal, but you as a programmer might be working with the network layer or might be working with the transport layer, and most of the time you work with applications layer. So applications layer could be one such view of a network, but someone might be working directly with the physical layer. That is another view of so you as a network programmer or network user can work with the different levels of the network system. One can work with the signal level, one can work with the packets level, one can work with the network layer protocol, one can work with the transport layer protocol, and most of the time we work with the applications layer. So accordingly, at what layer you work, we have different views of the network. Similarly, here also we have a different views of the database. And we talked about what are those different views of the data. Basic purpose of our talk is to talk about the basic concepts related to database management system. And this is one of the important concepts to understand what database management system is. So let's talk about, these are the three, look at this diagram now here. There are three different views of the database. Now look at this diagram, what we see now, we have the physical layer, what we say, sometimes called the physical layer like this one. One is concerned about how information is stored internally in the machine. Then the next level is what we call them the logical level. And finally, we have a different view of the data now. And we'll talk about here, we'll talk about all these things, what exactly we mean by physical level, what exactly we understand by the logical level, and what exactly we understand the different views of the database. That is very much important for you to understand. What the idea is that you understand how things happen inside. And not only that we learn simply query language and something like this, and that will comprise of everything. But we must understand how information are internally represented now. So let's talk about the physical level. And in fact, I have made analogy with the physical layer. So most of the concepts related to physical level you must understand in the same concept as physical layer of your network layer protocol. Now what is this one now? Look at this one now. We give you the definitions here. The physical lowest level of abstraction describes how data are actually stored. At the physical level, complex low-level data structures are described in detail. Might be byte by byte, might be bit by bit, or might be record by record, or might be block by block. So there are various informations are there. Few bytes might be one block, another few bytes might be the second block. So that is the architecture of information and so on. Database management system is designed around particular operating system environment. So depending upon how operating system provides this format, according database management system provides the storage of the database internally now. So depending upon, that is why I give you examples of some operating system provide you a storage of information in byte by byte form. Some provide a different format. So accordingly, database management system at the physical layer, depending upon what operating system they are designed around, accordingly they present the information now. And this is what one is concerned at the physical level. So physical level view of the database is internal level representation of the database, right? So the physical layer view of the network is the signal level representation of the data. Now let's go to the logical level. In fact, a database programmer, most of the database programmer is concerned with the logical level of the database now. Now what is the logical level? And then we'll try to make an analogy between the logical level of database and programming language. We will find some analogy between database at the logical level and the database view at the logical level, and then what is the analogy with the programming language constructs now. Look at this now what we have, some definitions related to the logical level here. It makes a higher level of abstraction. This is much more higher. You must remember this figure which we give you three different views of the database. The next higher level of abstraction describes what data are stored in the database and what relationship exists among these data. So they define the structure and they define the relationship among different structures. The entire database is just described in terms of a small number of relatively simple structures. So basically, what is this one now? What exactly the logical view of the database? The logical view of database is that when you create a database, you create a number of tables now. For example, when you write a program in programming language, or when you write a program in Java programming language, you define number of classes now. So each class you are defining one structure. So you can have a number of class type of structures in your program. Other programming language, you have a similar concept called record, or the, for example, in C language we have a structure is one such concept, union is another such concept, bit field is another such concept. In Java only class is one such concept. In Pascal and in Pascal programming language you have a structure is another concept. The record is another such concept. In other programming language might be another concept. In COBOL you have a record as a concept now. So when you write a program, you develop such structure now, and you can have a large number of such structures, and then actually you define some relationship among these structures and so on. So this is called a logical level view of your database, where you define number of structures and also define the relationship among these structures, and then you generate different types of queries out of it. So more complex structure, more difficult queries you have to form them, and more reports you can generate out of it. So this is called logical view of data. And then finally on the top you are user. So the programmer is sitting at the logical view of the database, but the user is basically one can get different views of the data. For example, take you to the relative evaluation system, the example which we started now in the beginning. So the logical view of the relative evaluation systems will be that I have a record about the chain, that about the chain timing, chain number, number of seats available in this chain, number of different classes are available in this chain, the journey and the stations it passes through, the time is spent at each station, time is spent between the two stations, time is spent from the beginning to the end. So this is all information related about the chain record. Accordingly, I can have information related to the passenger who has booked the ticket on a particular train and so on. And then a user can generate a different type of data. For example, I want to find how many people are traveling in Shatabdi on particular day. How many people are traveling by particular train on particular day between Delhi and some other station. So I can have a different view. The structures are constant there, but I can have different view depending upon my needs now. So and depending upon what exactly I want now. I want to know how many passengers belonging to this age group are traveling by this train and so on. So I can generate different statistics. In this case, I am sitting at the top level. I can very on the top level, so we say the view level and something like this. So this is basically, let me summarize very quickly what we are talking about. We are talking about internal issues related to database now. Just like, for example, you learn a programming language, you learn different data types, different constructs. In learning database management system, to understand database management system, you must understand what are the different views of the database model. At the physical level, we are talking about something else. Physical level, at the logical level, we are talking something else, and the top level, we are talking something else. And one must understand why we have three different views of the database. Now, the another concept related to database, what we call the instances and schemas. Now, let's define what is instances. Now, database changes over time as information is inserted and deleted. We keep on adding. More train inserted, more information will be added to it. Some trains have been cancelled, so train will be related records will be deleted from the database now. So database changes over time as information is inserted and deleted. The collection of information is stored in the database at a particular moment in time is called instance of the database. Overall database design is called database schema. So basically what we are talking about like this. So you must understand what is a database schema and what is the database instance of a database now, for example. For example, I have defined a record, I have defined a class now. Now I can create a number of objects of this class. So we say this is an instance. What is an object? In Java programming language, we say object is an instance of a class. So you define a structure and then I give various values to this one. Like I say class employee. So class employee simply gives you the structure. This is basically a schema. But I can have a number of employees in my department. So then I will define various values related to particular employee. So I can have a number of instances. So a schema will be only one, but I can have a number of instances of this type of a schema, depends on how many employees are working in our department. So this is called instance, and second one is called the schema. The structure, overall of the structure, template is called a schema, whereas the value given to this structure or template is called instances. So I have one schema but number of instances. Instances might be changing. Sometimes some employee have joined, so you have added more value, you have more instances. Sometimes some people leave the department instances, so you will have a less number of instances. Now let's go data independent. This is another important concept. For example, the concept is, otherwise you must understand, these are the basic issues which we are not talking about database management system, but we talk otherwise now. For example, when you have done a Java programming language, now Java programming, Java compiler produces the code independent of the platform. So that is underway. That is the trend today, that the operating system is being written independent of any platform, and this trend started with Unix operating system. When whole entire Unix was written except some part of the kernel into the C language. So, and same thing is happening today in programming language design. Now Java, the first programming language, in fact, the other programming language earlier also, which talks about they are not independent, they are independent of any type of environment. They are not using for particular type of environment, let's say the IBM or the Intel type of environment and so on. The Java compiler is independent. It means the Java compiler is independent. They produce the code independent of this one. Similarly, data independence is a concept which is very much important in database management system, and this is one of the important properties of a database management system. Now look at define what is a data independence. Now look at this slide. Now we have given some definitions of a data independence. The ability to modify a schema definitions in one level without affecting a schema definition in the next higher level is called data independence. There are two levels of data independence. So basically, if you want to modify one schema without which will not affect the design of another schema, we are talking about data independence. That way we try to understand now. But let's talk about what type of data independence we can achieve in database management system, or which is supported by database management systems. Now here today, right now, we are not talking about any particular type of database management system package. We are talking about basic concepts which comprise of any type of database packages now. So now first is called physical data independence. Now what is physical data independence? Now look at this now, see now. Physical data independence is the ability, is a feature to modify the physical schema without causing applications program to be rewritten. Modifications at the physical level are occasionally necessary to improve the performance. Something like this, what we do now is, what we are talking about is that you have created number of structure in the program, number of classes you have defined in your program, and then you write applications around these schemas. You write applications around these classes now. Now what we are talking about is that without changing the class, suppose you want to do some modifications. Earlier you have designed a class, employee class, where the name field was, let's say, something like this, of 20 characters. Now you want to increase them, or you want to add new fields in your class now. But your application program should not change. If application program is also being changed, it means that you have not ensured the independency characteristics now. By data independency means that you are modifying the database schema, the structure of the database, that is called what we call the employee database or the employee table, whatever it is. Then the application which manipulates this schema should not be changed. If it's changing, then the physical data independency is not ensured. If it is, means physical data independence, and this should be there. So the first important characteristics of the database management system, that it must ensure physical data independency characteristics. Let's look at the another characteristic now, what we call the logical data independency characteristic now. Now let's look at this definition now. Logical data independency is the feature or the ability to modify the logical schema without causing applications program to be written. Modifications at the logical level are necessary whenever the logical structure of the database is altered. For example, the money market accounts are added to the banking. So again, basically, in either you talk about the physical or the logical database, what exactly we are meaning is that you make any changes in the schema or sub-schema, that your application program should not be changed. That is the basic idea. Now, the concept of, let me try to give you some other examples now here. Try to compare with the programming language now. Now here is the concept of data independency. Look at this slide now. The concept of data independence is very similar to many respects of the concept of a stack data type in modern programming language. Both hide implementations details from the user. we allow just to concentrate on the general structure rather than on low-level implementation research. Basically, what we are talking about is just like what we have in the programming language now. Programming language, we say it is a structured data type. So, for example, you say you define integer x. Now, integer x is not a structured data type. The moment you say integer x, it is how much memory it will be taking, that is fixed now. And in the size of the data type, size of memory, it will keep on vary depending upon type of implementation. But we have a what we call them record data type. It is called what we call them is called abstract data types now. So very similar, the concept which we have here is very similar to abstract data types. Logical data independency or the physical data independency is very similar to abstract data types in the programming language. One should not be concerned about how the abstract data types have been implemented, right? And one can write applications. Or if you want to change the value or structure of the abstract data type, it will not affect your rewriting or your program, or you have to rewrite your program. So this is called what we call them that database management system, just like a programming language supports data independency, but without changing the applications, one can change the structure of the program. Now let's talk about the data models now. We have different data models. For example, we have different programming language models. We say that object-oriented is one programming language model. We say that procedural-oriented programming language is another programming language model. We say functional-oriented is another programming language. So each programming language are having own model. Not necessarily, but it might have that many programming language might be belonging to the same model. Like for example, C++ or Java programming language, they all belong to ISIL. For example, they all Smalltalk. They all belong to one programming model where the object is the main key concept or class is the key concept. So one model can have number of programming language candidates now. Similarly, in database models also we have different type of models now. Depends on how information or how database is structured inside or how database is represented inside. Similarly, for example, in hardware also, we have different type of models. Like for example, Pentium 1, Pentium 2, 3, 4, then we have a 3x6, 4x6, all different type of processor models. Similarly, we have a programming models. We have different operating system models. Unix is separate from a window entity. They are separate from the Linux is a separate model. Of course, a lot of similarity might be there, but the different operating system models are there. The different operating system models will mean how informations are internally represented. That could be one feature. There could be many other features to differentiate between different models now. So here we are talking about how database is represented. We have different type of schema or different type of records, how they are connected together, how they are linked together, how they are manipulated. So manipulation will be dependent upon how informations are internally represented now. We will talk about few such models are there. Now what are the three basic models are there? The different models, we have number of database program packages. Like we say Microsoft Access, again we have a FoxPro, FoxBase, we have a RAPL, we have a Ingress, we have a Sybase. So all are database models, but the model is only one. They all are database packages, but model is only one. Earlier we have the IMS that package supported by the IBM. They have entirely different type of models. So we'll talk about what are those models are there, and talk about one or two such models now. So here is, look at the slide now. Underlying the structure of a database is the data model. That is the basic, that is the heart of understanding of your database management system. A collection of conceptual tools for describing data. How data, you must have a tool to describe the data, must have a tool to define the schema, what we are talking about. Just like a programming language is a tool to define a class, the relationship between different data, relationship between different classes, just like programming languages, data semantics, consistency constants, which we discussed earlier. So must have a tool to define all those things. The various data models that have been proposed fall into just three groups. The number of packages are very, very large, but the models are just two. We say object-based logical model, one such model. Record-based logical model could be another such model, and the physical model that could be third models now. And we'll talk about one few such models. So we say relational database falls into one of such model. ER database model falls into any of this one. Hierarchical database might be falling into one of these three models and so on. So let's talk about the what is called. Now we have done this type of task, might be in CS02, must we have defined this type of exercise, we must have done CSI04, we must have done this type of exercise. We'll talk about, so entity relationship is a one object-based logical model. Now what a ER model is there? Just we'll talk about. Now look at this slide now. The ER database model, this is a model. It is based on the perceptions of a real-world entity that consists of collection of basic objects called entities and of relationships among these objects. So basically what they are talking about, what ER model says, ER model is basically, from ER model point of view, that all the real-world objects which you see might be, they are treated as entities. So when you are creating a database model, using ER model, then you are conceptualizing your problem in terms of number of entity sets. Like employee could be one entity set, the students could be another entity set, and so on. And there could be another entity set which will define the relationship between various type of entities. So here is the problem is to identify what are the real world entities like students entity, employee entities, and so on, and then establish the relationship among these entities. This is called ER based model. Now let me define what these terms are called entity now. You must have some exposure to this because we have done some many projects related to it. But anyway, let's define now. Now, entity is a thing or an object in the real world that is distinguishable from other objects. Like employees could be one entity set. It is different from a student type of entity now. They have different objectives, they have different job profile. Employees could be different type of employees. For example, our university, there could be in the chancellor also employee, the registrar could be another employee, but they all are employees. So here is entity is a thing or object in the real world that is distinguishable from other objects. For example, each person is an entity. Bank account can be considered to be another entities, and entities are described in database by set of attributes. How we define the employee? We define the employee entity through set of attributes. Name, employee must have some name. Employee must be given some code. He must have the salary, must have some designations, and so on. Must have some hobby. So all are part. They all attributes define what is the entity now. And one entity differs from another entity in terms of the types of attributes, the number of attributes, and so on. So this is what we have. Now the entity relationship is another which defines. Now what is the relationship is an association among several entities. So we define several entities just like we define several classes, and then we find out some another entity will establish the relationship between this one. I will show you through diagram. For example, a depositor relationship associates customer with each account that C had. The set of, right, there must be some. Another entity will establish a relationship between customer and account and so on. The set of all entities of the same type and set of all the relationships of the same type are termed an entity sets and a relationship. For example, I have a number of employees. For example, so employee is the one entity, but I can have a number of instances of the employee, so they all become employee entity sets. Similarly, I can have a number of entities which defines the relationship among two types of entities. Right? It could be three types of entities and so on, depending upon the complexity of relationship among different entities. So they will call a relationship entity sets. Okay, so we are talking about two types of entity sets in ER model, the entity sets model and what we call the relationship sets model. Now this is one such example. Look at this diagram and see now here is the account could be one entity set, one entity, customer is another entity set, entity. With the depositor is a relationship entity which establishes a relationship between customer. Customer can have n number of accounts, or customer can have only one account, or customer can have different types of accounts, and so on, depending upon what is the bank policy now. And each account, each entity is described by different types of attributes. Balance is one attribute. The account number could be another attribute. The customer is another attribute belonging to this entity, and so on. Sometimes we have not shown here, but also some say what type of relationship is it, one to one, one to many, and so on. One-to-one means each customer will have only one account. One-to-many of the customers can have a number of accounts and so on. So that is also defined. Here we have shown you the relationship between only two entities, customer and the account, but there could be relationship between three entities. So in that case, we say is a ternary type of relationship. What is called binary relationship. In ternary relationship, they are much more complex. And finally, this entity are represented inside the machine through a particular table and so on. So as many entities, so many tables. As many relationships, so many tables. And finally, you write an applications involving all those entity sets now. Let's have some more discussion. So please focus on this ER model because there's something you strongly work on any database problem. Finally, you have to build a designing of the database using this type of model. Identifying entity, identifying the entity sets, identifying the relationship entity sets, defining the attributes for each entity sets, and so on. Establish what type of relationship it is, there one-to-one, binary, and so on. Now let's talk about now let's continue with this one. Now overall logical structure of a database can be expressed graphically. So this way graphically. So here is a graphical model for representing a database and relationship and various data items now, which is built from the following components. Just like for example, you design a flow diagram, basically show the flow of information from one to another and so on. Similarly, this is how many entities, what are the relationship and so on. Now here is the ER model based data representations will contain number of components now. A rectangle which represents entity sets, ellipsis which represents attributes, the diamonds, again there is a standard is given which represents a relationship among entity sets. So the positive we put them into diamond type of relationship because we establish a relationship between customer and accounts. The lines which link attributes to entity sets and entity sets to relations. So these are the lines, diamonds, ellipses, rectangles. These are the various components to which we describe. Just like we define, we have number of different components to define the data flow diagram. Similarly, we have number of different components we can define. The another component which I have left here is that something we also define the level of relationship or type of relationship. That number will come 1 to 1, 1 to 10 and something like this. Finally, we will be working most of the time with a relational type of model. Your Microsoft Access is a relational database model. Your Oracle is a relational database model. SQL Server is a relational database model. The commonality between all the relational database model-based packages is that information representation is common now. So how the informations are represented, that defines what type of model we have. In a relational database, the basic thing that information is represented in form of a table. So what exactly is, let's have what we have now. The relational model uses a collection of tables to represent both data and the relationship among those data. Each table has multiple columns and each column has a unique name. That is the basic data structure, what we call them. What is the basic data structure in the relational model? The table is the basic data structure. There we have basically entity is one data structure. The relationship could be another data structure now. But here finally the entity is also represented in form of, but ER diagram is basically graphical representation. ER diagram, each entity can be represented through set of tables now. Depending on how many entities you have. The relationship can be also represented in form of a tables now. Now what is the table? Now table you have a multiple columns, you have a multiple rows and so on. We talk about the characteristics of a tables now. Now look at this example here. We have given you one example of a sample relational database model where we have defined the first column, this is the second column, each column will be name and all the information within the same column will be of same data types. Like here we have all are in the integer types. If you have account number, all are account number types now. They all will have the same. So there are many characteristics of the tables now. Now, the another database model which is not so popular, we are not going to work, but was quite popular in the previous days, what we call the network model. Now, how information are represented in form of a network model? Look at this slide now. Now, data in the network models are represented by collection of records. just the way you define a records in COBOL or the task assembly, you define a number of records to describe the information about particular object or entity. So data in the network model are represented by collection of records, and the relationship among data are represented by links which can be viewed as a pointers. The records in the database are organized as a collection of arbitrary graphs. It's very similar to what we call the ER diagram and so on. There is much more complex way of representing the information now. So we are not talking much on the relational database model, because finally we are going to work with the relational model itself. What advantages? List down few key advantages of the relational database model. Number one, look at this slide. Simple and based on mathematical theory. So the theory behind it, and that theory is based on mathematical theory of the relationship. The details of the storage structure and the access methods are known to users. But you know this, which all information are stored in form of a table now. The three basic components are there of any. If you want to understand the theory behind the RDBMS, one is look at different set of domains and set of relationships. These are if you want to understand any database packages, you must understand here the set of domains and sets of relations, operations and relations, and integrity rate. These three are basic components of any relational database model. And we'll talk about very quickly about these three components now. Now, what is the relations now? Let's define the term is called what we call in relational database model. So first we have to define what is the relations now. One table is one relation. The relations can be viewed as a table. One relation is one table. Two relations could be two tables, which have the following properties. They must follow certain properties. First, it is a column homogeneous. What is a column homogeneous? It means that given a given column of a table, all items are of the same kind. This is what we described earlier. That all items within the given column must be of same data type. You cannot have, it's like what we have in array now. When you define an array, all items of your array must be of same type. Not that one item will be of integer, another item will be of character, a third item will be of float. So when you say array, it means that they are somehow column homogeneous type. Means all the items within this array must be of same type. Whereas a record or subroutine, or if you define a record or if you define a class, each element of a class might be a different type. Let's say name could be string type, this age could be integer type, salary could be a float type, and so on. So depending upon what we have. So here what we say, the relation means one table, and in each table you have a column homogeneous characteristics where all elements with the all data types or all data items within that column must be of same type. Now each item, now here is the, again let's continue with each item, each data item which is defined within the array or the column must be simple number. It cannot be very complex data type. It must be a simple number of the characteristics. It might be integer, might be a float, might be a string, and so on. But right, and we say in the relational database model jargon that each table must be in first normal form. We talk about, we have still some time, we talk about what is a normal form. So each table, no one to define a table, it already becomes in first normal form. Right, you must normalize your database. When you are working with a heavy project, you must define, you must normalize them that so that it takes minimum storage and so on. Another important characteristics of your table is all rows of tables are distinct. So all the rows are distinct data types it can have. The ordering of rows within the table is in the table. So that I have defined a 5 rows table, but I can reshuffle them, and the meaning of the table or the semantics of the table remains the same. So these are the two important characteristics of your table or of your relational database model now. Each column that you must take care when you define your own relations. We are defining your own table now. The column of the table are assigned different name they all have. All columns have a different name. If you cannot have two names same name for two different columns now. And the ordering of these columns is immaterial. Just like, for example, I have 20 columns, I can easily reshuffle them. 20 days, I can easily reshuffle them. But all the data items within the column must be of same type. So there are two another important things are that when we are talking about database management system, one important concept of a database management system is first that what is the basic data structure, what are the basic properties of that data structure. We have already answered the table is the basic data structure, and the characteristics of the table already defined. The another important characteristic of the database management system of relational database category is the integrity rules, and that must understand. This one I was trying to define when we are talking about the drawbacks of the file processing system. Let's talk about one such rule. We say what is called integrity rule. Integrity rule number 1, what we call them entity integrity. Integrity number 2, they call it essential integrity. In fact, when the code, they are called code commandments, the 12 code commandments, which will help you to understand what exactly the RDBMS is. Right? So, and the integrity rules have been defined in these commandments. We talk about integrity rules. We have seen very important core concept of a RDBMS now. Now, what is integrity rule number 1? Look at this slide now. It is concerned with the primary key value. Right? The primary, you must have some key called primary, which is unique key. You know this key, you will be able to retrieve all the information. For example, if you know the student's enrollment number, all information related to the students, you will be able to retrieve them. So this is called, let me just read now, it is concerned with the primary key value. What it is? If the attribute of a relation R is a prime attribute of R, then A cannot accept null value. That is what we are talking about is that the primary key is able to retrieve all the information about the object or about the entity now. Like a student's database, for example. So if you know the student's enrollment number, that is a unique number. No, two students cannot have the same enrollment number. They might have the same name, might have the same addresses, might have the same date of birth. Right? So if you have a duplicity, then you cannot have those fields as a what we call them primary key. Primary key must be unique one. So primary key, when you are defining those relationships, the primary key should not be a null. It always must have some unique value. That is basically we are talking about the integrity rule 1. Let's talk about the last one, what we call them integrity rule 2. What exactly? Look at this slide now. It is concerned with the foreign keys, where we are talking about not one table, but we are talking about multiple such tables now, or at least 2 tables now. It is concerned with the foreign key, that is, it attribute of a relations having domains that are those of the primary key of another relationship. And we have the materials which we have got, they describe such informations about the integrity rule 2 also. Now here is now another important component of your RDBMS is called the relational algebra. So while studying the RDBMS, you have to understand some concepts related to the relational algebra. Look at this slide very quickly. Now it specifies 2 types of operations to be performed on existing relations to devise a. So whenever you make a query to SQL, they are basically based on this type of operation inside. And there are 2 types of operation, what we call them set-oriented operations and called relational-oriented operations. And just list them finally. They are called union, difference, intersection. They are called set-oriented operations. And finally, the relational-oriented operations are called join, selections, projections, division. So these are called business. Anyway, let me just finalize what we have discussed today. We just simply introduce you the concept of a database management system. What is a database management system? What are the basic characteristics of database management system? What are the drawbacks of the file processing systems? What are the different views of the database management systems? What are different database models? We gave you the relational database models and entity relationship models are there. What are the important data structures for representing relational database models? And finally, what are the important characteristics of a relational database models? What type of operations you can do on relational database management and so on. This is all we have. Thank you very much.